Adding 1 to both sides of equation 7, going back up to that one, we see that 2 equals 1. Snooki and the carrot are two different things. Therefore, they are one thing. All right? This is the problem with 0. All right? It messes things up. All right? What's wrong with this proof? And you'll go over this towards the end of your semester. What's wrong with this proof? Well, really, the only thing wrong with it is from equations 4 to 5. And look back on your notes on that. All right? Since A and B, we said A divide by A minus B. But since A and B are both equal to 1, then A minus B equals 1 minus 1 equals 0. We have divided by 0, and we get the ridiculous statement that 1 equals 0. We can use the same math program to prove that George Bush is a camel. All right. We can use the same thing to prove that the Ford Edsel is the top-selling car in the world. You know, we can do all sorts of things. 0 messes with our logic, and so does infinity. It opens up possibilities, it destroys things, it gives us all kinds of fits that are out there. Most cultures still avoid 0. Merchant cultures, why use 0? You don't need it. All of this talking we're doing tonight and thinking about it, in Thai culture, they would consider that a mental disease. Overthinking things is a mental illness in Thai culture. They've got a phrase called "mai pin lai." It doesn't matter. It doesn't matter. Right? Mai pin lai. It doesn't matter. Don't worry about it. Don't think about it. So if we got into a philosophical discussion about 0 with a Thai waiter, he'd say "mai pin lai." Right? It doesn't matter. Don't worry about it. You know, you're not going to order 0 drinks. If you do, you're not going to stay here. All right? You don't come in and say, "I want 0 beers." You know, there's just nobody. How many people would go in and order 0? I want 0 burgers and fries. No, I want multiple burgers and fries with bacon on the burger. I'm not going to order 0 burgers. You know, if I'm not going to have a burger, I'm not going to tell the waiter, "I'm not having a burger tonight." Well, I'm not serving you that burger. You know, wait a minute, that gets into a paradox. I'm not having. Well, then I'm not serving you that burger. Well, that works out. All right. So it becomes kind of a dangerous thing for us. It becomes kind of a funky little thing that happens within there. Any questions? Not about the Snooki complex. All right, that one bothers me too. It violates my norms. It's not geometry. It's not trig.
So is there infinity?
Yes. Infinity and 0 are one and the same thing. I mean, if you get in calculus with limits, we're going to work with that. I mean, there are functional limits that come about that we now, because we grasp from 0, because we work with it. Okay. And the church had a problem. Fibonacci brought in 0. All right, he brought it in. They had a problem with it. Then the church kind of relented a little bit because, well, okay, you know, maybe Aristotle wasn't always correct, and maybe we can have a void, and we can have 0. But then when the church got threatened, when Henry VIII started separating out from the Catholic Church, and then Martin Luther started separating out, the church went back to Aristotelian thought and rejected 0 and infinity again. And so it kind of went back and forth.
So there's infinity in all directions?
Yes.
And 0 in all directions?
Yes.
Even this way?
Yes.
Wow. Okay.
Philosophically, it's a weird concept. India, the Hindu tradition would teach you very much. The Rig Veda, the Bhagavad Gita, most of the Vedic texts spend a lot of time talking about the 0 and the infinite.
Do you think that's because of how much 0 is incorporated in our culture that there's going to be a day when it goes away? Or do you think since it's here, it's staying?
Mathematically, especially for like engineering math, I don't think we could get away with. I don't think we could get rid of 0.
Well, not with banking and all the different computer applications. I mean, it's mostly it's used as a place marker anymore. I mean, if you're looking at your bank statement, you could conceivably have negative balances, but that 0 point would be the break-even point. And so
how
I think
come
it's
people still argue about it? I mean, if it can't go anywhere.
Well, it's
what is it that people are like?
I mean, it's, you know, our calendars give us bits with 0s. You know, some of us remember the millennium better than others. But you know, you had lots of people who booked their reservations for December 31st, 1999 to usher in the new millennium. Well, no, January 1st, 2000, because of the way we set up our calendar, was actually the year 1999 AD. The real millennium began on January 1st, 2001. All right, the Maya took care of that by starting with 0. The early calendars, the Gregorian and Julian calendar, started with year 1, and so they kind of get off on things because they kind of took 0 out of there. They didn't use it when they recalculated. They figured, well, if you go by the calendar, Jesus was actually born in 4 BC. Actually, he was born in 3 BC if we do it properly, because they went 1 minus 1. It's like, no, there's a 0 in there. But think in terms of our popular culture. What did they have the big dedication for on Sunday in New York City? 9/11. At what location? Ground zero. All right. Well, you go to ground zero. When you're calibrating electronic instruments, you're going for the 0 point. All right. You zero in on something. It's become culturally a very important part of what we do. 0 hour is when things start, or when things end, depending on what you're going through. So, you know. Now, there's still a lot of cultures that 0 just doesn't matter to them. You know, I mean, hunters and gatherers, Australian Aborigines, they're not going to bother with 0. It's not out there. And for most merchants, even if you're in the construction trade, you very rarely bother with 0, other than you want to have 0 pieces of rebar left over at the end of the job if you're doing your estimations right. But you're never going to measure a board that's 0 inches long. But you will 0 in your saw to make sure it's cutting in the right locations.
So if you're like an engineer, that's no. Oh, well, I would say like you're an
Go.
if you're an engineer, though, you would use 0, though, right?
Yeah. Engineers are going to use 0 because, I mean, think about when you work with graphs, when you work with a number of starting things, you have a 0 point that you're beginning with. And 0 does allow you to come up with limits. And when those of you going into engineering, some of the structural mechanics that you'll work with are problems in calculus and differential equations that are going to deal with limits. And you've got to have 0 in there to be able to understand load strengths within construction.
I didn't understand what you meant by 0 and like why Aristotle would reject 0. Does it have something to do with his perception of God? Or
It did. It had to do with his perception of God. And for the Greeks, 0 was problematic. And it's still problematic for us. 0 doesn't add anything to numbers. It doesn't take away. The Greeks never dealt with negative numbers either. I mean, their geometry, their mathematics was all about measuring area and volume. And you can't have negative area. The Greeks just, you couldn't do that. You couldn't say, well, 2 acres minus 3 acres. They would never think about doing it. You couldn't take 3 acres away from 2 acres. It just is physically impossible. So 0 doesn't work within their mindset. And the Greeks didn't really like irrational numbers, but from time to time you had to have them. You know, you can have a right triangle, you know, but Pythagorean theorem, a squared plus b squared equals c squared. Well, if you're in construction, if you've ever worked in construction, if you want to square something up, measure out one corner to 3 feet, measure out the other one to 4 feet, and then on those 2 points, measure them until they're 5 feet apart. All right. Well, you've got nice, even, whole numbers to work with. But if both sides are 4 feet long, your hypotenuse is not going to be an even number. So they admitted they worked with the rational 0. They just upset them. They didn't like it. The whole concept of void. And still, even for some religious scholars, the concept of void is still bothersome. We still struggle with that philosophically.
yeah, because why though? Because they see God as
Well, all right, think about it. If you take Judeo-Christian Islamic creation, all right, at the beginning there was nothing. There was void. And then God formed the universe. Well, void sounds good, but what did that universe form out of? And so that's where that becomes the philosophical part in your question about can you have 0 or infinity going out in all directions? And that's where Aristotle had problems, was that this concept that there was absolutely nothing would mean, well, there wasn't even a God to put it together until at some point in time. And so that becomes the philosophical side of 0. And numerically, again, because numbers are magic, for people like the Greeks, the concept then of a number like that is actually kind of frightening. You know, because that challenges your entire cosmology, challenges your entire belief system. And infinity bothered them too. They admitted, you know, the universe that was a sphere within a sphere, but they did not believe there was an infinite number of spheres. It was like, no, there was a final sphere that stopped everything. That there would be this final point that we couldn't go past.
Do you think math is the language of God?
You know what? Actually,
Probably legal for an answer.
It might be. Now, one of the things I do in my anthropology classes, one of their discussion questions, when we're talking about language, one of their discussion questions I have them work on is defend math as a real language. You know, that we're used to language. People say, well, it's got subject, verb, and object and all that. Well, you've got some of the same things going on in mathematics. There are certain people that spend a lot of time working with mathematics who would say, yes, math is the language of God or the gods of some creation force. Going back to the Greeks, the golden ratio, that 1 to, the Greeks were big on proportions. Other things get past Snooki. Snooki bothers me. She is orange. And the Romans, again, the only thing the Romans did good in mathematics, well, it wasn't anything good in mathematics. Their main contribution to mathematics was the Roman soldier who killed Archimedes. The Romans came into Syracuse, finally took it over. They hated Archimedes because he developed all the machines of war that kept the Romans out for so long. As legend has it, Archimedes is doing a math problem in the dirt. You know, his mind's on something, and the soldier orders him to leave, and he won't because he hasn't finished his proof yet. So the soldier whacks him. So that's Rome's contribution to math. 1 to 1.618. And this is one of the few irrational numbers that the Greeks would actually work with. Pythagoras, the golden ratio. This one comes up over and over again in nature. If you look at studies of beauty or what's attractive, the human face, the layout, the width times height, the width being 1, the height is almost always on what we classify as attractive people, 1.618 times the width.
How's that in nature, though? I mean, I've heard that about...
In nature,
Yeah.
the rings on the pineapple, the spiral rings on a pineapple, measure out, each one gets increasingly a little 1.618 times larger. If you cut a nautilus shell in half, each chamber is 1.618 times the size of the chamber before it. Fibonacci, most of you know him from the show Numbers, and he comes up with the Fibonacci sequence. He did kind of this rabbit thing. You know, if you have a generation of rabbits and they have rabbits, okay, well then, you know, how many generations, now how many rabbits we have next time? Well, that one generation that was just was born is too young, but so you still have just the one, but then you get 2. And then 1 and 2 is 3, and then 2 and 3 is 5, and then 5 and 3 is 8, all right, that it keeps going over. And he kind of did that as kind of a math experiment. But if you take the Fibonacci sequence, and you take a number as a percentage or a portion of the number before it, 8/5 comes up to 1.61 something. 13/8, which would be the next number in that series, comes up to 13, or 8 is 13 is 1.618 times larger than 8. The whole sequence, if you go out as far as you can, it keeps repeating. And this is one of those quirky things in nature that comes up. Now the Greeks used this, and they looked for it in nature. They also used it. Their construction, the Parthenon, Athena, Nike, all of their important construction, all the important temples, even the Romans did it, are 1.618 times longer than they are wide. In architecture, my outside field's in architecture today, that is still considered an ideal. That's the classic shape of something that works without there. If you draw a rectangle with a height of 1 and a length of 1.618, and you cut a square out of it, 1, 1, 1, on all sides, the remaining rectangle, its length is going to be 1.618 times wide greater than its width. If you cut a square out of that, it maintains the same proportions all the way through within it. So is math the language of God? I don't know. Number made numbers. You know, I look for number patterns and all sorts of things. It drives everybody around me nuts. Because I'll come up with really far-fetched ideas. And there are people that spend their entire lives looking at numbers and looking for patterns. Any other questions? It doesn't have to be about math either.
Which Maya calendar ran out, the ritual one or the solstice?
Both.
Are both going to run
Yeah,
out
they're
at the
both
same
running at the same
time?
time. Actually, this occurrence, that's why the big deal is that it all runs out at the same time. Right? This just happens to be one of the end century cycles. And then the Maya also had like a super century. They've got blockings of centuries which are equivalent to our millennia and things like that. But again, the ancient Mayans, calendar scholars who did this, and they're very skilled in astronomy, and that's part of the reason why they were doing this, is to keep up with the astronomical calendars and the cycles. But yeah, you build a calendar that lasts for 1,200 years. You finally get to a point where you're like, okay, guys, we're done. Let's take a break. Somebody, We've got this figured out 1,400 years. In 1,300 years, we'll even know, hey, guys, when there's 100 years left, start this up again. Get this going. It's just like when the millennium hit. The big concern over the millennium when 2001 hit.